Good morning, everybody. I'm very glad to present our work about the evaluation of aerodynamic and structural performance of active composite driven by embedded small wires. This work is in collaboration with the group Stellantis, and the aim of this project is the design of active aerodynamic surface to increase the efficiency of the vehicle. In particular, we start talking about the SMA properties and our thermomechanical characterization, the design of our prototype, and the test of this prototype, and our conclusion, of course. For the beginning, I want to talk about the functional properties of this particular material. In particular, we can talk about the pseudoelasticity or shape memory effect. We want to use the shape memory effect to realize our prototype, and this effect consists in the recovering of residual deformation presets on this material, in particular on this wire, through the thermal activation. As we can see on the graph, the properties of this material is very related to temperature and stress applied. For this reason, we must do some tests to understand how these parameters are related. And in particular, we construct this setup to acquire the load applied on the wire by an hanging mass, the linear transducer to register to acquire the displacement, and a thermocamera to acquire the temperature on the wire. Thanks to the Joule effect, we can activate this wire and register and acquire the displacement of this wire. These are thermoelectrical test. Also, we can see after 20 cycle, around 20 cycle, the characteristics are stabilized, and we acquire the last cycle as shown in the figure. This is the thermal curve, the heating and the cooling curve. And thanks to a tensile test, we can evaluate the mechanical parameter such as the Young module, and we can we can construct the phase diagram. Okay, starting from this data, we develop our prototype as shown in figure. And this prototype is made by a plate as an elastic element made by a PC plus PS material and a silicon material to isolate the wire from the environment, and to terminal aluminum end part to crimp the wire. Okay, after the design of this element, we carried out some virtual tests thanks to the program console and the geomechanics module, in which the small wire was treated like a bar present inside the reinforced concrete. In this software, the SMA behavior are modeled by the Lagudas model, in which the parameters is the same of the test of before. Okay, we can see our prototype in function, and this with no load applied. And in the second video, we can see how the pressure of the wind affects on the plate in terms of vibration and deformation. And we can conclude that the pressure and the stress applied obviously on the wire change the shape of this element. And we must compute with coupled physics simulation the effects of the wind. To define the pressure on this plate, we use also already console, and we define a control volume to simulate the wind tunnel. And this is our test in the wind gallery. And in conclusion, we see that the model predict well the behavior of this element with no load, and for thermal problem of dissipation, we can improve our model, but the deformation is very similar. For future development, we want to install our device on a vehicle and test them to understand the efficiency. Okay. Okay. Thank you.